Hello, everyone, and welcome back to Ask Wall Street. I hope you're having a wonderful day wherever you're watching from. Here in Vancouver, it's a typical summer day, but the biggest story today isn't happening outside. It's happening in artificial intelligence. Moonshot AI has just released Kimi K3, and within hours, developers, researchers, and investors started asking the same question. Is this one of the best AI models in the world? Today, we're going to answer that question, but not by simply reading benchmark charts. Instead, we're going to understand what those benchmarks actually measure, what Kimi K3 is really good at, and why investors should care. So, what exactly happened? Over the past few days, one name has been appearing across the AI community, Kimi K3. Developed by the Chinese startup Moonshot AI, Kimi K3 was released with benchmark results that immediately attracted attention from developers, researchers, and technology analysts around the world. Some evaluations suggest it performs competitively with leading models from companies like OpenAI, Anthropic, and Google in areas such as software engineering, mathematics, scientific reasoning, and complex problem solving. Naturally, headlines quickly appeared claiming that Kimi K3 had become one of the world's best AI models. But here's the important question. What do those benchmark numbers actually tell us? Does scoring higher on a benchmark really mean one AI model is better than another? To answer that, we first need to understand what Kimi K3 was actually designed to do. Before we look at benchmark scores, let's first understand what Kimi K3 actually is. Think about how most people use AI today. We ask a question, the AI gives us an answer, and the conversation ends. But the next generation of AI is moving beyond simply answering questions. It's being designed to complete work. Imagine you ask an AI to build a website for your new coffee shop. A traditional chatbot might generate some code or suggest a design. A more capable AI system can break the project into smaller tasks, write the code, test it, identify problems, fix bugs, and continue improving the result until the website is ready. Instead of acting like a search engine, it behaves more like a digital teammate. That's the direction Kimi K3 is designed for. Rather than focusing only on conversations, it aims to handle longer, more complex tasks that require planning, reasoning, coding, and using multiple tools together. But how do researchers actually measure whether an AI can do those things? That's where benchmarks come in. Now we've come to the question that almost every AI headline skips. What exactly is a benchmark? Think about the Olympics. If someone wins the 100-meter sprint, would you automatically call him the world's greatest athlete? Of course not. A swimmer trains for completely different events. A gymnast develops different skills. A weightlifter competes in an entirely different discipline. They're all exceptional athletes, but they're being tested in different ways. AI models work exactly the same way. There isn't one exam that tells us which model is the best. Instead, there are many benchmarks, and each one measures a different ability. Some evaluate coding, others focus on mathematics. Some test scientific reasoning, others measure how well an AI can complete complex tasks over multiple steps. So when you read a headline saying, this AI is number one, the real question isn't, is it the best? It's the best at what? That's exactly what we'll explore next. Now that we know every benchmark measures a different skill, let's look at the four you'll see most often when new AI models are released. The first is SWE-bench. Imagine giving an AI access to a real software project with a bug hidden somewhere inside thousands of lines of code. The AI has to understand the problem, modify the code correctly, and pass every test. If it succeeds, it earns a point. This benchmark measures whether an AI can actually work like a software engineer, not, not just explain programming. Next comes AIME. This isn't ordinary school math. It's based on one of the most challenging mathematics competitions for high school students. The problems require logical reasoning and creative thinking, not just calculation. Then there's GPQA. Think of sitting for an interview with a PhD scientist. These questions cover advanced topics in physics, biology, and chemistry, testing whether an AI can reason through difficult scientific problems. Finally, there's humanity's last exam. Despite its dramatic name, it's simply one of the toughest AI evaluations available today. It combines expert level questions from many disciplines, including science, mathematics, medicine, engineering, economics, and law. Instead of measuring one skill, it challenges how well an AI can reason across many different domains. So now, when we look at Kimi K3's benchmark results, we'll know exactly what each score is actually measuring. Now comes the question we've been building toward. How did Kimi K3 actually perform? Across many of today's most widely used AI benchmarks, Kimi K3 delivered highly competitive results. It performed strongly on software engineering tasks, demonstrating that it can solve real coding problems, not just explain programming concepts. It also achieved impressive results in advanced mathematics and scientific reasoning, showing that it can tackle complex analytical problems across multiple disciplines. And on broad evaluations that combine many different kinds of expert level questions, Kimi K3 proved it can reason across a wide range of subjects, not just one specialized area. But here's the most important takeaway. These benchmark results don't mean Kimi K3 is automatically the best AI model for every situation. Just like Olympic athletes, different AI models excel in different events. Some are stronger at programming. Others may still be better at writing, creativity, conversations, or multimodal tasks. What Kimi K3 demonstrates is that the gap between the world's leading AI models is becoming smaller and competition is becoming much more intense. So, why does all of this matter beyond the AI community? Because every improvement in AI capability creates demand somewhere else. If AI models become better at writing software, conducting research, solving scientific problems, and completing complex business tasks, companies will rely on them more often. That means more AI workloads running every day. More AI workloads require more computing power. More computing power means more GPUs. More GPUs require more advanced chips. Those chips need high bandwidth memory, advanced packaging, faster networking, and massive cloud infrastructure. In other words, one breakthrough in AI software can create demand across the entire semiconductor ecosystem. That's why investors aren't only watching companies that build AI models, they're also watching the companies that make AI possible. Companies like NVIDIA, TSMC, Broadcom, Micron, SK Hynix, and the major cloud providers. Whether Kimi K3 becomes the industry's leading model or not, one thing is becoming increasingly clear. The competition in AI is accelerating, and every major advance pushes the entire technology ecosystem forward. That's why it's worth paying attention, not just as a technology story, but as a business story. If you enjoyed this breakdown, don't forget to like the video, subscribe to Ask Wall Street, and let me know in the comments which AI model or technology should we explore next. Thanks for watching, and I see you in the next episode.